గెలిచింది, గమ్యం తెలిసింది, ప్రతి అడుగు ముందుకే విజయం మనదే. నమ్ముకో నిన్ను నువ్వు, నిన్ను మించిన వారు లేరు. ఈ క్షణం నీ సొంతం చేరాలి నువ్వు టోపు. ఉన్నత శిఖరల వైకుంఠ దర్శనం, నీలోని శక్తి నిత్య ప్రబోధం. అగదు ఈ పయనం, తగ్గదు ఈ తేజం. ఇండియా గెట్ రెడీ, మనది విజయం. విజయం విజయం.
Conclusion. When they are both in parallel, dot product or neural product. When they are perpendicular, that will be the orthogonal. What means? These are the qubits. Because we are related to quantum computing, we are discussing. So, main concept of the qubit, how it can be. So, when the qubits like it moves parallel, so that time that states of that qubit it must be 1. Understood? These symbols I will explain later what are the symbols. So both vectors 5, 5. That must be equal to 1. The size. Understood? Now, when they are parallel, that it must be 1. That is the norm of the qubit. Okay? Now, when they are perpendicular, 0 vector one side and 1 vector one side. Entirely different. So, what it means? We will get in orthogonal, we will get only either 0 or only one value. We can't take both because both are different directions. So, we will get only one value, either 0 or 1, not 0 and. Understood? So, this is the concepts of the inner product and orthogonal product. When they are parallel vectors or when they are perpendicular. Understood? Now, in system there are number of spaces. Now we know only general spaces, that is vector space. Understood? Now there is a second one, Euclidean space. Whatever it may be, whatever the space it is, there you have to find the length of the vector. Direction will be the same, that is not affected. But only thing is distance or length of. So in any space we are going to talk about the length of the vector. So same here in Euclidean also space we have. How? In Euclidean. Euclidean space means that is related to the geometric space. Means this Euclidean space is based on geometry. Geometry how? In normal what we know the coordinate systems like this x and y. Sorry, x, y. This is one type of space. Means this is two-dimensional. Two dimensions, x and y. Understood? There is another dimensional. This is three-dimensional. Like this is x, and this is y and this is. Normally this two-dimensional we are going to use for the qubits, how the vectors can be. Taking any point of that will be the x-axis and y. And this one for mostly we are going to use apply for the images normally, this answer. So in geometry, till now geometry either two-dimensional or this one is three-dimensional. Based on that, we are going to find the length of the vectors. Okay. So here in this formula, length of the vector, can you decide d equal to square root of, if we take two vectors, okay, first one x1 minus x2 whole square plus second vector y1 minus y2 whole square, that will be the square root of it. Understood? For any Euclidean space, that is geometry, either two-dimensional or three-dimensional, there you are going to take the length of the vectors, that is in this way d equal to square root of x1 minus x2, that is first vector, second vector. Similarly y1 minus y2 coordinates. In this way we can find the length of the vectors. Understood? Now let's talk about the next space, that is metric space. Metric space is the concept of finding the distance between vectors. Distance between vectors. Because that is the most important for the qubits. Because qubits two states. Now what about the two vectors and what will be the state? Distance. That is the most important topic in qubits in quantum computing. How they are different. Either they are equal or they are perpendicular. For that we have to know the metric space. The formula will be the distance of a comma b. Vectors, both are vectors. Two vectors. That equal to modulus of a minus b. This is the formula for this. This one we can later we will discuss how easily we can implement this. But just you should know the concept of what is metric space. Just for finding the distance between two vectors. That is the most important for the qubits. Because how the qubits are. Qubit means two. That how the two bits are. Whether they are in parallel or same direction or in different direction. That must be find out first. Then only we can get the pure results. Correct measurements. Understood? Now, so Euclidean space. So this basically depends upon the geometrical. It means either two-dimensional or three-dimensional. So two-dimensional means there are two coordinates, x and y. Three-dimensional is three sides, x, y, z. Understood? This is two-dimensional and this is three-dimensional. So when it comes to the Euclidean space, here also we have to find the distance, means length. But it is a geometrical space. It means there is a dimensions, isn't it? Here two dimensions and these dimensions. Maybe later four dimensions. So when this type of geometrical structure, then finding the length, vectors. So that is everything depends upon length and angle. both must be there. While calculating the length, we have to see the angle also. So these are the both quantities of the Euclidean space. So see for example, x-axis and y-axis. So both are passing like this, and there will be angle. See, between these two angles there is 90 degrees. The x vector is moving like this. Understood? So how y vector is moving with the 90 degrees angle, its y is moving up. Understood? Y will require the angle. Similarly here also x, y, z. If any moves like this, either x side is moving, it is angle, and moving to y axis, maybe it will be 90 degrees or it will be 60 degrees. So total from here to this angle. Then only we can find the length. Understood? So concept of the Euclidean space, that is related to the geometric space. So here we have to find the vector space or length based on angle. Okay. Now coming to the Banach space. What is Banach space? It is also for length of the vector only. To find what it must contain, the quantity of this. First of all, you should have a vector space to find the length of the Banach space. See, first you should have a vector space, and it should have a norm. What is the norm in quantum? That is alpha square plus beta square equal to 1. This is the norm. Means in this Banach space, you must have a vector space and you should have a norm, should be satisfied. And third one, that there must not be any gaps. Means no gaps. For example, say roads, vehicles are passing or walking or passing, what are the roads? If roads are not yet developed or properly done it, then there will be stones or holes like what. When the road is properly structured, everything parallel, everything nicely, they have done it. Road without any holes or without any stones or that is parallel, smooth. Well, then vehicle go smoothly without any problem, without any interruptions or without any gaps. It can move freely. Understood? So that only we are saying in Banach space, we should have a vector space where we can construct the road. Understood? And you should have a norm. Norm is to create such a road. We should follow the norms. What are the norms? Properly stones and mixing, cement mixing, sand mixing, everything. Normally we have to make it. Then only we can create a road without any gaps. Understood? Total structure. So that is Banach space. Next, coming to another space, that is Hilbert space. This Hilbert space is entirely related to quantum computing. So, what is it? It is also must have vector space, English. Hilbert space must have vector space. And first we discuss about the product, inner product. Where we use the inner product? When the two vectors are passing parallel, then at that moment we are going to discuss about the inner product, how they can communicate, talk when they are parallel. So that concept you must have. Then finally, we should have a Banach space. Understood? When you combine these three, then it is a Hilbert space. What is Banach space? Banach space is, one is, it must have vector space and it must have norm and second, third one, no gaps. Understood? So, covering all this, that is Hilbert space. This is most important in quantum. How the quantum states can be, find the length. Understood? So, I remember this one. So, finally, what this Hilbert space gives is the most important space in quantum. Okay? What quantum? He should satisfy. It must complex numbers, because qubits having a complex, because that formula we know, alpha square plus beta square. These both are complex numbers and norm equal to 1. That one we discussed here, is it now? So that is must satisfy the complex numbers, Hilbert space. And second one, having more probabilities, finding the probabilities. Miscalculations. What are the probabilities will be for finding the length or distance or angles, whatever the probabilities we can calculate in this Hilbert space. The opportunity is given by the Hilbert space. Okay. Next, doing operations. So these are the three possibilities which are mainly required in quantum computing. Understood? That will come from the Hilbert space. Understood? Now coming to the next. Final space, that is Minkowski. Minkowski space. This is also finding the difference between the vectors or finding the length order maybe. Mostly it is using for relativity. Here relativity means relation. How, for example, if the both are passing together, how they are passing based on the timings. Okay. See, for one this one is moving and this one is two vectors. Let's take A and B. How they are passing, how we can calculate? Based on the time. May, for example, for 1 minute time, may it move 5 kilometers. Or maybe this one, for 1 minute of time, may it move 10 kilometers. Understood? So, here, for the finding the length, we are going to apply the timing sensors. Got it? So, with 1 minute of time, it is taken 5 kilometers distance, and this second one, with 1 minute of time, it is taken 10 kilometers. Means the relation between these two, based on the time sense. So, based on time, how we can find the Minkowski space. So based on that, we have to find the distance that implies. X square plus y square plus z square minus e square t square. As if I am taking here three-dimensional. X, y, z. X square value, y square value, z square value. Minus complex numbers of squares plus timing square. So this is the formula for finding the Minkowski space. Just a relativity, both vectors. Okay. Finally, we come to the block sphere. This block sphere is the visual representation of a qubit, single qubit. Understood? Qubit representation as visual representation of a qubit that can be shown in block sphere. How block sphere will do? Because see, how we can give the qubits to the system when we discuss about the coin rotation. Remember, this is states 1 or 2. One side head and one side head. They are like 0 or 1. Tail and head. Coin rotation. So that is round. So here also, block sphere means it will be like round shape. Means rotating. This is the coin rotating. Understood? So, taken dimensions x and y value. Let's take x equal to y value. So here positive and here negative values, and here positive, here negative values. So how it will be the this one y value top will be the 0, and here it will be the 1. Top 0 state and down 1 state. Understood? Same here also x value, y value, 0 or 1 state. Understood? In this manner. So this is a block sphere is the visual representation of the qubit. Okay, understood? And wherever it may be in this block sphere, any vector. Vector means which will be having a direction and amplitude, length. For example, this is a vector This vector can move like this rotation or like this rotation. May this vector can rotate like this, or may vector like this, or maybe this vector can be like this rotation. What it means? So any vector can be located in this block sphere. Understood? So finally, this block sphere is used for just to visualize the single graphical representation. So later we will discuss about these things when we are going to talk about the gates. Okay, that time we will discuss. So before that, this much is sufficient for you. Understood? About the topics we completed today. Now spaces. What are the spaces available? Okay. Now what we discussed till now regarding spaces. First one is vector. What is vector? That is a arrow of, like a arrow. So the direction and distance vector. Now coming to the vector space. Vector space, group of vectors. Understood? Means possibilities of root or roots. Possibility of roots means number of vectors and each having some roots, how they are going to move. The vector space. Next comes to the Euclidean space. What is Euclidean? Especially for the quantum base. Euclidean space. What quantum base? Can you recall? Memory?
మన భూమి మన గుండె మన ఊపిరి ఉన్నత శిఖరల వైకుంఠ దర్శనం నీలోని శక్తి నిత్య ప్రబోధం అగదు ఈ పయనం తగ్గదు ఈ తేజం ఇండియా గెట్ రెడీ మనది విజయం హే 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 విజయం విజయం ఇది మన కథ ఇది మన విజయం లెట్స్ గో